What happens when galaxies collide? What happens to the billions of stars and planets? When galaxies collide, one of the most profound effects is the gravitational interaction between stars and other matter within the galaxies. The gravitational forces at play during a galactic collision can have far-reaching consequences, as the gravity each star exerts can disrupt the delicate balance within star systems. This can destabilize entire planetary systems, altering their orbits and even ejecting stars from their host galaxies. Imagine what would happen to our solar system if the orbit of Jupiter was altered even just slightly. At the heart of the issue is the way gravity shapes the motion of stars within a galaxy. In a stable galaxy, stars follow relatively predictable orbits around the galactic center, influenced by the gravity of nearby stars, dark matter, and the galaxy's overall mass. However, when galaxies collide, the introduction of new gravitational forces from another galaxy can cause significant disturbances. As galaxies approach each other, the gravitational pull from both galaxies begins to act on individual stars. This interaction can disrupt the orbital paths of stars and, by extension, the star systems they host. In many cases, stars can be flung into new orbits, thrown into intergalactic space, or moved to different regions within the merging galaxy. For star systems with planets, this movement can spell disaster. Stars are typically orbited by planets, moons, and other smaller celestial bodies. These systems are held together by the star's gravity, which keeps planets in relatively stable orbits. When a galaxy collides with another, the gravitational forces exerted by nearby stars can alter the orbits of these planets, potentially destabilizing the system. For example, if a star is perturbed by the gravitational influence of another star or passes through a region of intense gravitational interaction, its planets could be shifted to new, more elliptical orbits. In some cases, the disturbance could be so strong that planets are ejected from their orbits altogether, turning them into rogue planets, drifting through space without a host star. Such events could also lead to collisions between planets or moons within the same star system, resulting in massive destruction. Imagine the consequences for Earth if our moon's orbit was dramatically altered by a passing star, or if the Earth's orbit was pulled further out from the Sun. This would lower global temperatures, resulting in mass ecological extinctions and alter the delicate balance of life on our planet. The gravitational pull between galaxies during a collision often creates what are known as tidal forces. These forces stretch and distort galaxies, forming long streams of stars, gas, and dust that extend far beyond the galaxy's core. These structures, known as tidal tails, are a visible result of the gravitational interaction between colliding galaxies. Tidal forces don't just act on a galactic scale, they can also affect individual star systems. In some cases, stars can be torn from their galaxies entirely, sent off into intergalactic space to wander the cosmos alone, forever. These gravitational forces can strip away the outer layers of a galaxy, reshuffling its stars and gas clouds in a process that significantly alters its structure. One of the major effects of a galactic collision is the loss of stability that stars enjoyed within their galaxy. Stars typically move in stable, orderly orbits around the galactic center. However, the gravitational disruption from a collision throws this delicate balance into chaos. Stars are accelerated or decelerated as they respond to the gravitational pull of the incoming galaxy, and their paths are dramatically altered. As galaxies merge, this instability can lead to the structure of the galaxy being dramatically transformed. Spiral galaxies, for example, may lose their distinct spiral arms, resulting in a merger that very often forms an elliptical galaxy. This new combined structure represents a reshuffling of stars, gas, and dust, and the balance that once held stars in their orbits is now completely altered. While the gravitational chaos of a galactic collision can cause significant disruption, it can also create regions of intense star formation. The gravitational forces compress clouds of gas and dust, causing them to collapse and form new stars in what is known as a starburst. This phenomenon creates massive clusters of new stars, often shining brightly and adding to the spectacle of the collision. However, the formation of these new stars comes at a cost. The rapid star formation can quickly deplete the available gas and dust in the galaxies, leading to a period of intense activity followed by a long decline. Once the gas is consumed, the merged galaxy may become a dead galaxy, one where little or no new star formation occurs. The gravitational interactions during a galactic collision also affect the supermassive black holes at the centers of the galaxies. As the galaxies merge, their central black holes are drawn together by their mutual gravity, eventually forming a binary black hole system. Over time, these black holes spiral closer together, losing energy in the form of gravitational waves until they finally merge in a cataclysmic event. This black hole merger releases an enormous burst of gravitational waves and results in the formation of a single, more massive black hole. The merged black hole can be highly energetic, powering active galactic nuclei or quasars that shine brightly across the universe. This process is a spectacular consequence of galactic collisions and can have significant implications for the structure and behavior of the new galaxy. While stars themselves rarely collide during galactic mergers, the gravity each star exerts plays a crucial role in shaping the outcome of the collision. Gravitational interactions between stars, planetary systems, and gas clouds can lead to the disruption and destabilization of star systems, throwing stars and planets into new orbits or even ejecting them from galaxies entirely. The gravitational forces also give rise to starburst regions, tidal tails, and the merging of supermassive black holes, creating some of the most extraordinary and awe-inspiring events in the universe. Galactic collisions are a process of cosmic destruction and creation. While they can destroy the delicate balance of star systems and alter the structure of galaxies, they also lead to the birth of new stars, the merging of black holes, and the transformation of the universe's most massive structures. These interactions, though violent and chaotic, are a fundamental part of the ongoing evolution of the cosmos, reminding us of the dynamic and ever-changing nature of the universe. We hope you enjoyed our look at colliding galaxies and invite you back to experience another episode